Okay, future value is usually a pretty straightforward concept, but let's move on to present value. Present value is working backwards. So you might say, I want to have $1,000 in 1 year. I know I can get a 10% interest rate. Yeah, right. Not in this market, but wouldn't it be nice? What do I have to put in the bank today so that a year from now I will have $1,000? So you're going to move on to the next table. So turn in your books to table 3, present value of $1. Okay, so interest rate 10% in is 1 year, that first year. And you're going to look for the intersection of 10% and 1, and you'll see the factor is less than 1. It's 0.90909, and that is what you will multiply by your future value amount. The $909 is your calculation for present value. If I put $909 in the bank today and I earn 10%, at the end of the year it will be worth $1,000. And this is great for calculating preparing for future expenditures like the college fund or like a vacation. Present value is also known by another name as discounting. Why? Because money now can earn interest and it'll be worth more later. It'll have a higher amount later. Well, this is everybody's favorite problem. You win the lottery and you have to choose between receiving $10,000 at the end of 3 years or receiving the discounted amount today. So, single amount, we're going to use present value, table 3, and at the end of 3 years you're going to receive $10,000. What would they pay you if you needed and wanted your money now? So again, look at the intersection of 3, 8%, and you get your factor, 0.79383. Again, it's less than 1 because we're discounting it. Multiply that by 10,000. If they pay you today, you get about $7,900. If you wait, they'll pay you $10,000 because they're building in the interest, the 8% interest. All right, let's finish these 4 examples. There's 4 big examples, and the last one is present value of an annuity. And this is what I like to call the car buying problem. The example I'm going to show you is going to be for annual payments, but you could adjust this to make it monthly payments as well. So instead of paying off my car over time, what if I paid cash now? So I'm making payments of $10,000 for the next 3 years. If I choose not to pay on time but pay in cash, what would they charge me? Now, you know and I know that if you pay now, you should pay less. So again, set up your variables because this is a great way to keep track of which type of problem you're doing. And again, remember, if we're using a payment, we're either going to use future value or present value, but not both, because the payment takes the place of the other item. If you use Excel to calculate future value and present value, you'll actually have a drop-down menu with these variables in it, and you'll load them up. All right, we want to know what the value is today, so our present value is going to be a question mark. And do follow along in your course pack and fill this out, and then you'll have a sample to work with. Interest rate we know in 3 years, and then since it is an annuity, we're going to go to table 4 in your textbook and look at the intersection of 10% and equals 3. And you're going to find that amount, and the factor is 2.48685. So if you pay today, you're going to pay $2,486.86. This should be a comma. If you pay over time, you'll pay $3,000. So you get a discount of $513 if you pay now because you don't have to pay the interest. If you can't afford the $2,487, then you're going to pay over time $1,000 a year. And a lot of us have had to make that decision, right? We've said, I don't have the $2,400 now, but I can scrounge up $1,000 once a year. So let's do a quick practice problem. Kildare Company signs a lease. It's a lease to own, and it requires annual payments of $6,000. If you pay the lease off up front, how much would you pay? Well, over time, and those are, you can see they're not exactly equal, but assume they are equal. Over time, you're going to make 5 payments. This is a very typical annuity problem. Built into those 5 payments is a 12% interest rate. But if I pay today, I should pay less than $30,000. So you're going to multiply 6,000 times your factor. So look that up. Go to the 12% column, go to 5 years, find that factor. And the factor is 3.60478 times 6,000 is 21,000. Now we used a really big interest rate here to demonstrate the value of paying cash now. Not having to pay 12% interest saves you what? $9,400, $8,400. So that's quite a bit. Now please take a note, when you're on that annuity table, your factor has to be less than N. N in this problem is 5 years, and your factor is less than 5. If you get a number that's greater than N, then you know you've made an error. Appendix C, applications. That's always the part where we put all this to work. In Chapter 10, you studied bonds. Bonds are issued at face value, discount, or premium. We know the bond selling price depends on market interest rate, face value, discount, premium. If it's face value, that means the market rate equals the contract rate. If it's discounted, the market rate is more attractive, and we had to put our bond on sale. We have the ugly bond. If we're selling our bond at premium, that means the market rate, that means we're selling higher than face value, and the market rate is less than our bond contract rate. We have the pretty bond. How do you calculate the selling price of bonds? Well, first off, you need to know the bond interest rate, and that is the contract rate, and that is only used to calculate the bond interest payment amount. That will be the face value of the bond, and that's $1,000 times the number of bonds issued. So face value of the bond issuance, and you need to know bond interest payments. So you use that contract rate to calculate the cash. That's what we're asking here. How much do you actually pay out each interest payment date? And then finally, you need to know the current market rate, and that is the number you are going to use with your tables. The bond interest rate, you only use that to calculate the interest payment amount. So you're going to have 2 interest rates in these problems, and it's a little tricky to remember which one you use. But you only use the bond contract rate to calculate the interest payment. You use the market rate to calculate the selling price of the bond. This concludes part 1 of Appendix C. Please go on to part 2. We're going to show some examples. I'm going to show some examples on calculating bond selling price.